Beautiful, thank you. Yay. Kia ora koutou katoa, ko Laura tōku ingoa. My name is Laura, and today I'll be talking about classifying nearshore marine habitat for restoration purposes. And a lot of this is built on the back of free and open source software, so I'm very thankful to all of you here. So, globally, but also in New Zealand, there's quite a rocky reef ecological imbalance, just to give some context. Kelp forests are amazing, we love them. They provide us so much in terms of ecosystem services, like fisheries, nitrogen removal, carbon sequestration, but these are in decline, and a lot of that is due to climate change, pollution, but also a funny problem, which is sea urchin overgrazing. So in New Zealand, about a lot of the northeastern coast of New Zealand, we've got these things called sea urchin barrens, and you can see my manager swimming over the top of one up there. So their predators have been overfished, the population explodes, and they eat all of the kelp. So a bit of an issue. So my work established a charitable trust called Ocean Regeneration Aotearoa, and the aim of the game is to find these sea urchin barrens, clear them out, because there's some great research that suggests that if you clear about a hectare, healthy kelp forest will regrow within about 2 years, which is amazing. But we do start to see barrens reforming at like the 2.5 year mark. So monitoring, reporting, verification is really crucial. We're also wanting to use that to prove biodiversity uplift, so we can get funding through a sort of a biodiversity credit system. But we are a charitable trust, so there's budget constraints, scientific divers and vessels, time. So seeing an opportunity for Earth observation and open source to map nearshore habitats so we can track regeneration. So went out with a drone, captured some imagery at our site Moturika, which is in the Hauraki Gulf here and just in the waters around Auckland. We also got validation data through snorkel survey. The problem with classifying marine environment is there is water in the way. So we adapted the Depth-Invariant Index to really isolate the effect of the seabed, which kind of like puts a filter over it. You guys know what NDVI is and all that jazz. So the original bands, you can see the habitat classes, their mean reflectance. It's pretty close together, but once we applied DII, they spread out quite nicely. So we classified the environment pretty well, fed it through a random forest model in Python, and it's done pretty well, which is quite exciting for a pilot. Got a good F1 score for our validation data. It was great at classifying macroalgae and sand, so kelp forests and sand. Some trouble with cobbly bottom and rocky bottom, but that's because the spectral signatures are quite similar, so we expected that. And also a bit of a problem when we don't have validation data for an area, it's tricky to tell because there's water in the way, so optically it's hard to really confirm it as well. So I would really like to see species spectral signature libraries sort of being built. It would be very exciting. There was a 50-year retrospective study that claims that the species around the world in marine environments is quite spectrally similar, so it might be able to reduce fieldwork costs, which would be great for us. I'd also like to have a bit more rapid imagery collection, but it is very tricky in the ocean, especially in the near-shore environment. There's shadows and rough surfaces, and yeah, so it's hard. But we're aiming to be able to find these sea urchin barrens in a bit more of a wider sense and predict their future spread, but also track kelp recovery. And yeah, massive thank you to the whole team that's been involved in this, and it's my contact details in case anybody has questions or come find me later. Thank you.